we're going to do something pretty incredible right now. We're going to look back in time. And I don't just mean a few years or even a few million. No, we are going all the way back, back to the very moment the universe first switched on the lights. So let's see what this ancient signal has to tell us.
So what if I told you that you could actually see the echo of the Big Bang? I know, it sounds like something straight out of science fiction, right? But this isn't a what if, it's real. There's a signal we can actually pick up, this incredible afterglow that fills our entire sky.
And this is it. It might look like some kind of abstract painting, but what you're looking at is, without a doubt, the oldest photograph ever taken. Seriously, this is a map of our entire sky, showing us what the universe looked like when it was just a baby, a mere 380,000 years old. This, my friends, is the cosmic microwave background.
Okay, so what is this thing, really? For decades, it was a total mystery. Astronomers were picking up this signal, but it wasn't coming from any particular star or galaxy. It was coming from everywhere, every single direction in space, all at once. And it was almost perfectly uniform.
No matter where we point our telescopes, we detect this faint, constant hiss of microwaves. It's this cosmic background hum that's just everywhere. You can think of it like the leftover warmth from a giant oven. In this case, the Big Bang, that's cooled down over billions of years, its light stretched out into the microwave part of the spectrum. And when we measure its temperature, it is incredibly cold and unbelievably consistent. We're talking just 2.725 degrees above absolute zero, the coldest temperature possible. Now, that consistency is amazing, for sure. But here's the kicker. The real secret, the key to unlocking, well, everything, isn't in how uniform it is. Nope. It's in the tiny imperfections. You have to look really, really close, but the temperature isn't perfectly the same everywhere. It varies by these minuscule amounts. We're talking about 1 part in 100,000. And believe it or not, these tiny, almost insignificant fluctuations are what make this map one of the most important pictures in the history of science. So how on earth was this photograph even taken? Well, to get that, we need to take a trip back in time. Way back. To a time when the universe was a completely different beast. A time before a single star had even thought about shining. Imagine this. For the first 380,000 years of its life, the universe was this super hot, super dense fog. A soup of particles called a plasma. And it was so thick that light literally couldn't go anywhere. Photons, the particles of light, were just trapped, bouncing around off free electrons like a pinball. You couldn't see through it at all. The entire universe was opaque. But the universe was expanding, and as it expanded, it cooled down. And that cooling led to this one critical moment. See, when it got cool enough, electrons and protons could finally grab onto each other and form the very first neutral atoms. And just like that, poof, the fog cleared. All those trapped photons suddenly had a clear path to travel. For the very first time, light was set free. And that's the light we're seeing today. It's been traveling, uninterrupted, across the universe ever since that moment. Think about it. After a journey of 13.7 billion years, it's only just now arriving at our telescopes. So when we look at this map, we are literally seeing the light from that exact moment of cosmic dawn. Okay, so this ancient light is way more than just a pretty picture. It's a blueprint. A cosmic blueprint. It holds all the secrets to how our entire universe came to be. So, let's decode it. All right, let's circle back to those tiny little temperature differences we talked about. Remember, the hot and cold spots? Turns out, they are not just random static. No way. Those tiny spots, they are the seeds, the primordial seeds from which everything we see today grew. Every star, every galaxy, every giant cluster of galaxies, it all started right there. So how do you read this thing? It actually all comes down to gravity. Those slightly hotter spots, the red and yellow ones, they were areas that were just a little bit denser than the rest. And over billions of years, gravity did its thing, pulling more and more stuff into those spots until, bam, you get galaxies. And the cooler blue spots, well, they were a little less dense, and they eventually became the huge empty voids we see in space today. And this is where it gets really cool. By studying the patterns, like the size of these spots and how they're spread out, scientists can do something that sounds impossible. They can figure out the fundamental recipe for our entire universe, what it's actually made of. And get ready, because this is where things get really, really weird. The results are, well, they're shocking. It turns out that everything we know, everything we can see and touch, atoms, planets, stars, you and me, all of it makes up just 4% of the universe. Just 4%. The rest, about 21%, is this stuff called dark matter, an invisible glue holding galaxies together. And a whopping 75% is dark energy, some mysterious force that's making a universe expand faster and faster.
So that leaves us with one last massive question. If these little hot and cold spots were the seeds that grew into galaxies, what created the seeds in the first place? To answer that, we have to go back even further. I mean, way, way back, to the very first fraction of a second after the Big Bang.
Right now, our best idea for what happened is a theory called cosmic inflation, and it's a wild one. The idea is that in the first trillionth of a second, the universe just exploded in size. It went through this unbelievable growth spurt, expanding faster than the speed of light, going from smaller than an atom to something astronomically huge in basically no time at all.
And what's so mind-blowing about this idea is how it connects the teeniest, tiniest things with the biggest things imaginable. See, at the quantum level, space isn't actually empty. It's constantly fizzing with these tiny random energy fluctuations. Well, inflation took those microscopic jitters and stretched them out to cosmic size. And those stretched out quantum wobbles are what became the hot and cold spots we see in the cosmic microwave background.
Just take a second to let that sink in. Every single galaxy out there, every star, the massive cosmic web that fills our universe, it all started as a random microscopic flicker in the very first moment of time. So this ancient light doesn't just show us a baby picture of the cosmos, it reveals a direct, unbroken line connecting the strange, random world of quantum physics to the grandest structures we can possibly imagine.